Hi everyone, we are from Group 5. The title of this video is 5.4 Refraction of Waves.
Refraction of wave. Refraction of wave is the change in direction of propagation of waves caused by the change in the velocity of wave when the wave propagates from one medium to another. Smart info. Spin of water wave is influenced by depth of water. Spin of sound wave is influenced by density of air. Spin of light wave is influenced by optical densities of medium. Refraction of plain water wave. This picture shows the wave from the deep water lagoon to the shallow water lagoon. This picture shows that the wave from shallow water lagoon to deep water lagoon. Effect of refractions on the characteristics of wave. When the frequencies of deep water lagoon and shallow water lagoon is not changed, the wave spins and wavelength from the deep water lagoon to shallow water lagoon is decreased, and the angle of incidence is more than angle of refraction. So the direction of propagation is refract toward the normal. From the shallow water lagoons to deep water lagoons, the wavelength and spin length is increased, and the angle of incidence is smaller than angle of refraction. The direction of propagation from shallow water lagoon to deep water lagoon is refract away from the normal.
Now let us look at how to draw a diagram of refraction of plain water wave. Figure 5.37a shows plain wave front in deep water region approaching shallow water region, and Figure 5.37b which shows water front of refracted wave can be drawn using 4 steps. Step 1. Draw an arrow line AB perpendicular to the incident wave front to represent direction of propagation of the incident wave. Step 2. Draw the normal which is perpendicular to the boundary of the deep region and shallow region at B. Step 3. Draw an arrow line BC which is near the normal than AB to represent the direction of propagation of the refracted wave. And the step 4 is draw 3 lines perpendicular to BC to represent the refracted wavefront. The lines have to be closer to one another compared to the incident wavefront. Next, there are some smart info. If water wave propagates from shallow region to deep region, direction of propagation of the refracted wave is bent away from the normal.
Phenomena of refraction of waves in daily life. During the daytime, an observer cannot hear sound clearly, but during the night, the observer can hear the sound more clearly. This is all due to the effects of refraction of waves. During the day, air that is close to the surface is hotter than the air above. So the sound will move faster in hot air than cool air. As such, the sound is refracted away from the ground. During the night, air that is close to the surface is colder than the air above, and the sound is refracted towards the ground. So this is the reason why the sound from a distance can be heard more clearly during night than during the day. Refraction of sea waves. The cap is the shallow water region, and the base is the deep water region. Away from the shoreline, the wavefront of the water is almost straight and parallel because water waves move at a uniform speed. When the wavefront of water propagates to the cap, the speed water waves decreases, causing the wavelength to be shorter. And when wavefront of water approaching the bay move at a higher speed and the wavelength is longer, the wavefront to curve and follow the shape of the shoreline. The refraction of water waves causes the water wave energy to converge towards the cape. Water wave energy diverges from the bay and spread out to a wider region. Thus, the amplitude of the waves at bay is smaller than the cape.
Hi everyone, I'm Dr. Masinhui. Now I'd like to present solving problems involving refraction of waves. Refraction of waves caused by the change in speed of waves. For water wave, speed of wave changes when the depth of water changes. This also causes wavelength to change. Frequency of waves does not change because wave frequency is determined by the frequency of vibration at the source of the waves. This diagram shows that change in speed and wavelength when water wave propagate from deep region to shallow region. We can use this formula to calculate the speed of wave. That is V1 divided lambda 1 equal to V2 divided lambda 2. Now we want to see the example 1. A plane wave which has a wavelength of 2 cm and speed of 8 cm per second propagate across a shallow region. When the wave enters the deep region, wave speed becomes 12 cm per second. Determine the value of the wavelength in the deep region. This is the solution. Shallow region is lambda 1 equal to 2 cm, V1 equal to 8 cm per second. Deep region is V2 equal to 12 cm per second. Now we want to find this lambda 2. We use this formula. 8 divided 2 equal to 12 divided lambda 2. Lambda 2 equal to 12 multiply 2 divided by 8. And the answer is 3 cm. Next, we want to see the example 2. Figure 5.43 shows propagation of water wave from region P to region Q of different depths. Speed of the wave is 18 cm per second in region P. Determine the speed of wave in region Q. This is the solution. Lambda in region P is 12 divided 4 equal to 3 cm. Lambda in region Q is 12 divided 8 equal to 1.5 cm. The region P is lambda 1 equal to 3 cm. V1 equal to 18 cm per second. Region Q is lambda 2 equal to 1.5 cm. Now we want to find the V2 and we use this formula to find it. 18 divided by 3 equal to V2 divided by 1.5. V2 equal to 18 multiply 1.5 divided by 3 and the answer is 9 cm per second. That's all for our presentation. Thank you.